Number 15 says, approximate the area under the curve using left endpoint rectangles, right endpoint rectangles, and then midpoint rectangles. For the function f of x equals x cubed on the interval from 0 to 8 with 4 subintervals. Okay. The first thing that we need to find when we're doing a question like this is we need to find delta x, the change of x. And delta x in this case is equal to b minus a over n, such that a and b are the intervals on which x goes from, and n is the number of subintervals. So my a is 0, my b is 8, and n is going to be 4. So delta x is equal to b minus a divided by, 8 minus 0 divided by 4. There's going to be 8 over 4. There's going to be 2. Delta x equals to 2. All right. Now that we have delta x, I'm going to draw my number line. And our interval goes from 0 to 8. And remember, we have 4 subintervals. 2, 3, 4. So we should have 4 units in between 0 and 8. Unit 1, Unit 2, Unit 3, Unit 4. Delta x is 2. The change in x is positive 2. So that means I'm going to increase by 2's, starting at 0. This is 0. This is 2. This is 4. This is 6. And that's obviously 8. Now we're going to label. The starting value is the initial value. So we call this x sub 0. Actually, let's put it under here. X sub 0. X sub 1. X sub 2, X sub 3, X sub 4. Now that's going to be useful for helping us out in the future. Now it says you want to find the area under the curve using left endpoint rectangles. So to find left endpoint rectangles, the area using that's going to equal to delta x times, in brackets. Remember, it's going to be left oriented. So we start at x sub 0. So it's going to be f of x sub 0 plus f of x sub 1 plus f of x sub 2 all the way to f of x sub n minus 1. Close that bracket up. Now, if you notice here, it says all the way to x of n minus 1. N is 4, right? So if I plug 4 into my n right here, that's going to be x of 4 minus 1, and 4 minus 1 is 3. So if you notice, I must stop at x of 3. That's the highest I can go. And also, you're going to look at every point to the left. This is a left point. That's a left point. That's a left point. That's a left point. But this is on the right. If you look at these first two, x of 0 is on the left. If you look at these second two, x of 1 is on the left. Look at these two here. X of 2 is on the left. Look at these here. X of 3 is on the left. There's nothing else for me to look at. So L of 4 subintervals equals to delta x. Delta x is 2. And that's going to be in brackets times. Actually, let's put the 2 in a different color. Put it in purple instead. f of x sub 0, where that is 0, plus f of 2, because that's x sub 1, plus f of x sub 2, which is 4, plus f of x sub 3, which is 6, and close that up. Remember, our function f of x equals to x to the third power. So this is 2 on the outside. F of 0. Well, if I plug 0 into x to the third, f of 0 is 0 to the third, and that's just 0. So that is 0. And I encourage you guys to use your calculator. The reason why I can't use mine is because my tablet is too hot. Anyways, f of 2. We're plugging 2 into the function x to the third. 2 to the third power is 8. So that's going to be plus 8. F of 4. You could plug in 4 into your function x to the third. That's going to be 4 to the third, which is 64. Plus f of 6. You're plugging 6 into your function. F of 6 is 6 cubed, and that is 216. So that's going to be 2 times, add up those numbers. That's 8, that's 72. 72 plus 216, that is 288. And 288 times 2 is 576. So using left endpoint rectangles, I will get an area of 576. Now we're going to use right endpoint rectangles. And the formula is just slightly different, but it's kind of the same. It is delta x times, in brackets, f of x sub 1 plus f of x sub 2 plus all the way to f of x sub n. So to find the area of using right endpoints with 4 subintervals, there's going to be delta x. And delta x, once again, that is 2. So 2, put that in purple actually, times, we start off with x sub 1. X sub 1, that is 2. Let's zoom out just a little bit. So f of 2 plus f, that's going to be f of 4 plus x of 3 is going to be 6. So f of 6. And that's going to be plus f of x of 4, which is f of 8. And the reason why that we're going up to using 8 in this case is because if we plug the value of n, which is 4, down here, we can see that this will be x of 4. And plus, it's to the right. So you're going to look at every right point. This is a right point, that is a right point, that is a right point, and this is a right point. We found most of these already. So 2 in brackets, We know f of 2 is 8 already. We know that f of 4 is 64. We know that f of 6, that was 216. Then we have to add that with f of 8. So I'm going to plug 8 into my function. That's going to be 8 cubed, and that's 512. So let's add the numbers that are inside of the brackets and then multiply that by 2. We already know that 8 plus 64 plus 216. This is 588. 288. 288 plus 512, that is 800. And 2 times 800 is 1600. And that is the answer using right endpoints. So we can definitely see that using the left endpoint is a very, very, very small underestimation, or a very large underestimation. Using right endpoints is a very large overestimation. Now we're going to use the one that gives us the most accurate, which is the midpoint attempt. Let's scroll back up to the top. Now, when it comes to the midpoint, I have to use the middle number of each interval. So, for example, the middle number between 0 and 2, that is 1. So we're going to call that x bar of 1. And that's going to be positive 1. The middle value between 2 and 4, that's 3. So we're going to call this x bar of 2. Matter of fact, let's make some more room. I'm going to erase my delta x because I already know what that is. So this is x bar of 1, which is 1. X bar of 2, which is 3. The middle value between 4 and 6, that is 5. So that's x bar of 3, which equals to 5. And the middle value between 6 and 8, that's going to be 7. So x bar of 4 is 7. When it comes to the midpoint approximation, m is equal to delta x times, in brackets, f of x bar 1 plus f of x bar 2 plus f of, or rather, that goes on forever and ever and ever, dot, 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 plus f of x bar of n. And n is 4 in this case. So m of 4 is going to equal to delta x, which is already established to be 2. And in brackets, f of x bar of 1. X bar of 1 is 1. Plus f of x bar of 2. X bar of 2, that is 3. Plus f of x bar of 3, that is 5. Plus f of x bar 4, x bar 4 was 7. And now let's calculate. So that's going to be 2 in parentheses, f of 1. If we plug 1 into our function, 1 cubed is equal to 1. F of 3. If I plug 3 into my function, 3 cubed is 27. Plus f of 3. So rather f of 5. I plug 5 into my function. 5 cubed is 125. And if I plug 7 into my function, 7 to the third is 343. So now let's add inside the parentheses. 1 plus 27 is 28. 28 plus 125, that's going to be 153. And 153 plus 343. You know what? Instead of me just doing that, let's just do it. 1 plus 27 plus 125 plus 343. That's 496. Take that 496, times it by 2. There's our area, 992. So this is 496 times 2. 992. And there you go, guys. That is how you find the midpoint, the left and the right areas. Now, if you want to find the actual area, I'm just going to do that on the side real quick. Just take the integral. The antiderivative is going to go from x is 0 to x is 8 of x to the third power dx. When we take the antiderivative, we add 1 to the power, divide that by 3 plus 1. A is going to equal to, that's going to be x to the fourth over 4. And that's going to go between 0 and 8. Remember, when it comes to the definite integral, no plus c. Plug 8 into the function first. So 8 to the fourth over 4 minus, that's going to be 0 to the 4 over 4. This part here is going to be 4,096 over 4. That's just minus 0. And the actual area is going to be 1,024. The midpoint approximation comes the closest. All right, guys. I'll see you in the next one. Take care.